Hi everyone! Today we're going to get started with our notes on 7.6, which is our variation. So this is our last section of chapter 7. So let's finish it with a bang. First and foremost, we're going to be looking at all different types of variations. The most simplest one is what we call direct variation. So direct variation is when y varies directly as x if there exists a real number k such that y is equal to kx. So this first example that we're going to go through is a pretty basic direct variation. It says Bob is paid an hourly wage. 1 week he worked 43 hours and was paid $795.50. How much does he earn per hour? Okay, so our total amount of $795.50 is equal to the $43 we worked times how much we earned per hour. I'm going to use a p for my variable. So when I divide that out, we get our price per hour to be $18.50, right, per hour. That's how much we're making for our wage. So go ahead and try this one on your own. I'm going to keep on moving. I'm going to assume that you guys are pausing these, so pause me as you need it. So for this, try on your own. If a 7 kilogram of a steak costs $4.50, how much will 1 kilogram? So 45.50 is equal to 7, I don't know, x, I don't know what you use. When you divided that out, did you get 650? So it's 650 per 1 kilogram. All right, so it's just the easy dividing. It costs $52 to use 800 kilowatt hours of electricity. How much will 650 kilowatt hours cost? Okay, so here we would be doing our direct variation again. So we have 800 is equal to 52, I don't know, I'm going to use x. We could divide that by 52. So we get 800 divided by 52. So x is equal to 15.3846 and some change. So then if that's how much it is per kilowatt, per kilowatt hours, so now we need to figure out how much it's going to cost for 650. So I'm going to put that 650 in place of the 800. I'm going to put the 15.384 in place of my cost per x unknown. So when I divide that out, we get our x is 42.25. That's how much it would cost for 650. Another way we could have done this, as I was reading it, I was thinking kind of proportions. So couldn't we have just done 800 over 52 is equal to 650 over x and solved for x? That would have gotten you to the 42.25 also. So maybe that would be a little bit easier. All right, see if you can try. I guess there's going to try one on your own. All right, so solving a variation problem. The first thing we're going to do is write the variation equation. Second, we're going to substitute the initial values and solve for k. Then we're going to rewrite the variation equation with the value of k from step 2. And then 4, we're going to substitute the remaining values, solve for the unknown, and find the required answer. So your direct variation as a power. Here we have y varies directly as the nth power of x if there exists a real number k such that y equals kx to the n power. So in this example, it says the distance of a body falls from rest varies directly. So it's good to remember that whatever comes before the word varies is considered your y, and whatever comes after it is the stuff that varies. So the distance a body falls from rest, I'm going to use d for the distance the body falls, varies directly. So varies directly means we're going to have a k times something. So k times something, what is that something? The square of the time. So time squared, it falls. So there's my equation. If a skydiver falls 64 feet, so there's your distance, in 2 seconds, there's your time. Now we need to solve for our k. So solve that out. So 64 is equal to k times 4, dividing by 4. 64 divided by 4 is 16, is equal to k. So there's my k. So what's my new direct variation equation? Well, it's, oops, not y, it's d. d equals 16t squared. So now I found 16. 16 is my constant. It's always going to be there. Now I can put in a new d, or I could put a new t, and I come up with other answers. So we want to know how far will she fall in 8 seconds. Well, that's time, so I'm going to put that in for t. So my distance is going to be whatever 16 times 8 squared is, which is 64, is 1,024 feet, or in feet. Okay. All right, so try this one on your own. The amount of water emptied by a pipe varies directly as the square of the diameter. So the amount of water emptied by the pipe varies directly as the square of the diameter of the pipe. For a certain constant water flow, a pipe emptying into a canal will allow 200 gallons of water to escape in an hour. The diameter of the pipe is 6 inches. How much water would a 12-inch pipe empty into the canal in an hour, assuming the same water flow? So go ahead and pause this video, try it out, then come back. All right, so hopefully you did something like, I don't know. I'm going to put the amount of water emptied by a pipe. So empty, E for empty, maybe use W. I don't know, maybe I'll use water, I guess. Amount of water. Water varies directly as the square of the diameter. So varies directly. So K times the square of the diameter. For a constant water flow, a pipe emptying into a gallon will allow 200 gallons of water. So 200 in for W. K, the diameter is 6, so 6 squared. So 200 is equal to K times 36. 200 divided by 36 is 5.55555. So to keep it as exact as possible, I'm going to make that 50 over 9. So K is equal to 50 over 9. So that makes my equation W is equal to 50 over 9D squared. So now we want to know how much water would a 12-inch pipe empty into a canal in an hour. So W is equal to 50 over 9 times 12 squared. So on my calculator, I get an answer of 800. As long as I didn't round it, you should get exactly 800 gallons for your answer. Or if you did round it, you probably should have gotten something close to that. All right, now we're going to get into inverse variation. So inverse variation is when y varies inversely as x if there exists real numbers such that k, so number k such that y is equal to k over x. So notice with direct variation, it's k times x. With inverse variation, it's k over x. Also, y varies, we can have it vary inversely with the nth power of x too, so that could happen too. All right, so here's our example. In the manufacture of a certain medical syringe, the cost of producing the syringe varies inversely as the number produced. So always find that word varies, and notice what is in front of it. The stuff that's in front of it is your y. So the cost is my y. Varies inversely, so that means I'm going to have a k over something. What is that over something? The number produced. So I'm going to make it n. So if 10,000 syringes are produced, so there's my n. 10,000. What's the cost? $2 per syringe. So that gets me 20,000 for my constant of variation. So now what does my new equation look like? C is equal to 20,000 over N. So find the cost per syringe for producing 25,000. So 20,000 divided by 25,000 is going to be equal to our cost. 2500. So I get 0.8. So C is equal to 0.8 cents would be the cost per syringe. All right, try this one on your own. The current in a simple electrical circuit varies inversely as the resistance. If the current is 80 amps when the resistance is 10 ohms, find the current if the resistance is 16. Again, pause the video, try it out. So hopefully you came up with something like, this is the part, the current. So I'm going to use C for current, varies inversely, so K with the resistance, I'm going to use R. The current is 80 amps, resistance is 10, it gets our K to be 800. So my new equation is C is equal to 800 over your resistance. So find the current if the resistance is 16. So 800 over 16 is 50. So that would be 50 amps is my units. That's what you should have gotten there. All right, here's another example. Suppose P varies, so P varies inversely as the cube of Q. And okay, so P is 100 when Q is 3. So 100 times 3 to the third is 27. So multiply by 27 on both sides. So we get 2700 is equal to K. So my new equation is P is equal to 2700 over Q to the third. So then it says find P, given that Q is 5. So 2700 over 5 to the third. Oops, 2700 divided by 5 to the third. Should get 21.6 for your P. Okay, so direct variation. So now what we're going to do, or sorry, an inverse variation. Now what we're going to do is combine them all together. So that's called a joint variation. So joint variation is something like when y varies jointly as x and z if there exists a real number k such that y is equal to k, x, z, or some type of combination of everything. So here in this example, it says the interest on a loan or an investment is given by the formula I equals PRT. Here for the given principal P, the interest earned I varies jointly as the interest rate R and the time T. The principal is left earning interest. So here they already gave it to us. If an investment earns $100 interest, so we have I is equal to PRT. So I is 100. My P, it says, well, the same principal earned. So my P is what's constant. Our rate is 0.05. Our time is T. So 0.05 times 2 is 0.1. So this becomes 0.1 P is equal to 100. 100 divided by 0.1 tells me my P is 1,000. So I is equal to 1,000 RT. It's my new equation since my principal is the same. So what would it earn for 4.5% interest for 3 years? So 1,000 times 0.045 times 3 is $135. Would be our answer there. All right, here we're going to do body mass. The body mass index, or BMI, is used for physicians to access a person's level of fatness. A BMI from 19 through 25 is considered desirable. BMI varies directly. Okay, so there's the word vary. So BMI, so I'm going to do B for BMI, varies directly. So that means we're going to do a K times something. What is that something? Individual's weight in pounds, and inversely, so that means I'm going to put it over what? The square of the individual's height. So height squared. All right, so now let's fill in what they give us. They said a person who weighs 118 pounds and is 64 has, okay, so my BMI is 20 when we're 118 pounds and the person is 64 inches tall. So 64 squared is 4,096. Okay, times 118 over 4,096. Multiply by 4,096 on both sides. Times 20. So that gets me a really large number of 81,920 is equal to K times 118. Divide by 118. Tells me my K is about 694.237-ish. Okay. So now that makes my new equation. So we need to find B is equal to 694.237 W over H squared. Right? Our height is in inches, yeah. And then we're doing the BMI for 165 and 70. So 694.237. Height or weight is 165. Height is 70 inches. So let's figure this out. So times 165 divided by 70 squared gets me a BMI of about 23.4. Would be my BMI score. All right, that concludes your notes. So the moral of the story is find that word varies, put whatever is in front on the left side of your equal sign, then put a K. If it says directly, we're going to do a K times. If it says jointly, we're going to do a K divide, right? All right, that concludes your notes.